Hello. Today we're just gonna go over some of the topics from package 01 and 02. I'm gonna divide the package 02 into two meetings, so it's gonna be today and Friday. And today's meeting is going to be we're gonna have like a 10 minutes break because of Zoom. It doesn't allow me to go further than that. So yeah, we are also some announcements to make. Um, Today there is no package because whatever was gonna get released today got released on Monday, and whatever was gonna get released on Monday got released on Saturday. So we are just one day um, early. Yeah, just that. But we'll have a new package on Friday. But just try to do the problems from package 02 because I made some of the problems long and some problems are gonna be hard too. So yeah, just have that in mind. I start early if you can. And today I never got any package, which is fine. But you guys just make sure if you want to hear some feedback from me, just send them to me. It doesn't matter if you finish or not. Just send them to me, and I'll be able to get back to you to give you feedback on your work. So yeah, just have that in mind. Package 02 will be solved on Monday. So yeah, on Friday we're just gonna keep talking about package 02. With that being said, any questions yet? Okay, then if there are no questions before we start, we can get started by solving the put in practice problems from package 00. So this package was a little abstract, the instructions, just because I wanted you guys to think more with abstraction. I don't know if that makes sense for you guys, but for me that makes kind of a little sense. So let's see. The first problem, I'm not gonna solve it because I think everybody solved it. Number one also got solved, and 1.5 was also solved. So let's look program number two. First, for this program, we need to have some understanding on basic physics. And we kind of need to know how to calculate the mass. If you don't know how to calculate the mass, just look on Google. But this is the basic formula to calculate the mass. So if you know the weight, which is this, and then you know the acceleration, which was given, you can get the mass. So the mass is gonna be mass equals to the weight over the acceleration. So that's the basic idea in order to get this to get the answer, right? The mass. Then we need to know that the format kind of has to follow these. It doesn't need to follow these exactly, but we can follow that, right? And remember that the function input also takes a message which can be printed for the user, so the user know what the user is being asked to do. So if I just put a name in there and then a space and run it like that, the message name gets printed, and then I'm expected to write something to it, right? So I write my name there, and then nothing happens. That's okay because we are still writing this program. The input also takes that input And at this point, we don't need the name, right? We are not going to do anything else with the name. We just want to know the name, but we don't have to record it anywhere. We can record it in a variable, but we are trying to do a one-liner. So remember that the input is a string. So whatever I get from the user is going to be a string. And a string can be concatenated, right? So I can put a plus sign there to concatenate another string, and I can put another input message. So like this, and then I can ask for the last name, and then a space for just for so it doesn't look weird when inputting the information, and then I can put last name here. And you see how this is kind of taking the same format that I suggested here. And if you guys want to keep doing all the age and that, it's fine. I'm not gonna ask for the age because it's the same thing here, right? So I can just go ahead and ask for the weight. But before we get the weight, you guys gotta know that we are trying to solve for the mass, right? So I print mass, and then I put the colon in a space, and then I put a comma here. This comma, I don't have to put a space there because the comma puts the space for me. And then I know I need another string, right? So I put an input there, so I can get the weight. And then I can ask for the weight right after, weight, put the colon and a space. And from this point on, I'm expecting the weight or whatever the input you put to be an integer. And because that's going to be an integer, we need to transform it into that number, into an integer. So we put integer before the input, so it transforms the string into the integer, and then we divide by the acceleration, which was given 9.8. And then this is expected to work, right, at this point. But it won't work because every single, let me comment this out for a moment, and let me print a statement. So I'm gonna print a statement, and I want you guys to think about what the print statement is going to return, and it returns none. Why? Because every single function in Python, and we are gonna look at this right now, but every single function in Python returns something. And in this case, print returns none. And I want to transform that value into a string so it won't complain. And I have this, my weight, I don't know, I might just make up a number, and then I get the mass. And this is how you solve problem 2 in one. This is how you solve problem 2 in one single line of code. Okay. Now, if we look at problem number 3, we have to record the user's name, last name, age, and current year, and then calculate the year of the person. And then we gotta do it in one line. Similar to that, we can use the same structure, but just remember the, wait up, just a second. Okay, yeah. Just remember that, wait, what was I doing? Okay, yeah. Oh, okay. So we gotta record the important stuff, right? We need to know the age and the current year. So let's forget about the name and the last name right now. So let's just focus on the current year. So if we do print, and then we do current, you were born on, and then we put the colon, a space, and well, we don't need the space. We put a comma right after the string, and then we ask for the first input, age, and then colon, a space, And then this needs to be converted to an integer. So we convert it to an integer. And then we also need to do some math with the current year, right? So we get the current year. So input current year, and then we don't need to add it. We know that the current year has to be subtract the total age. So this has to be a negative number. So you just put the negative sign before. And by doing this, you should be able to get well, not that. Let me just comment this out. And okay. And then we ask for the age. Let's say, I don't know, 21, and then current year 1999, and it should give you the age, the year I was born, and that's not the year that I was born. Wait, let me try it again. 21, 1998. No. Sorry. 2020. Yeah, okay, it works. Yeah. So any questions? Okay, good. Okay, at this point, there are no more questions for the questions from package for the PIB 00. Now we are gonna move on to the PIB 01. But before I go there, okay, yeah, branches 01. We open, and then let's go to the putting practice. Do you guys look at this, or do you guys have any hard problems you guys want to go over first before me solving them? No? Okay, so I believe there are no questions. And I kind of, there's, what about the one from the year 3000? What do you mean? From the year 3000? From, wait, it should work. What is showing is going to be? Oh, no. I think. Oh, shoot. Oh, determine how old will the person be in the year 3000. Okay, yeah. So to do that in one line, I think I was overthinking that too much. You were born. You cannot put a comma in here because that will mess up that. Oh, but you can certainly do a plus sign here. So you can convert this into a string. And then, oh yeah, shoot. Okay. Yeah. So you can't not do that in one line. Sorry for that. I didn't think of that. I was just throwing information for you guys. But yeah, that cannot be done in one line. And the reason why is because you have to store this information here in a single how do you call it? I mean, you can do it in one line, but you gotta understand some concept first that I talked about in package 01. But that's not the point here. The point here is do it with whatever we learn in this package. So at this point, that cannot be done with that. So yeah, sorry for that. I was just trying to make it hard. Sorry, but yeah, to do that you have to do it in more than one line. So yeah, choose disregard that. No, I'm reading. Okay, so let's move on to the next putting practice problems. Here, I'm gonna go over these three last problems. So the structure here, like I said from the previous, it's gonna change. So the program 0, 1, and 2 are gonna be a little bit easier than program 100 and 101 and 102. So these three problems are gonna be harder. And I'm gonna start doing these problems. So the first one is going to ask for 5 inputs and store them in such list and then print it. And then it asked me to do it in one line, right? So I print a one line list, which should have 3 inputs from the user. Input, 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 and input. And then you can put number 5 input, and then I can just copy and paste this here. Number 4, number 3, and then number 2, number 3 here, and then number 1. And if we run this program, it should work. Number 1, let's just, I don't know, give whatever inputs you want. It doesn't have to be numbers. You can also put a strings. Hello world. And here you have it. And that's how you do it in one line. Okay, now let's comment that out and work on program 101. And then if the last input was not a numerical. Okay, so this is basically asking for me to ask for an input and I'm asked for a numerical input then. So, and I gotta store that number. Num is equals to the integer of the input of a number. Enter a number, colon and a space. And then it asked me to, oh, okay. So we don't know yet if the input is a numerical input. So we gotta do the following. If number not in 2, 3, 4, 5, 6, 7, 8, 9, or 0, if the number is not a numerical input, print an error message. Print an error message. Print not a number, not a number. Else, we do, all entries are the first input, increase entries, and print an error. Otherwise, print a list whose all entries are first input. Okay, so we are asking for 2 inputs, right? So just value, I guess, input, and then enter an input. And then if this was not an input, we print a list of the value times the integer of the number. And first we enter an input, let's say hello. Enter a number, let's say 4. And then it should work like this. But if you want to do it in one line, assuming that you have the correct input, you gotta do it this way. So you first want to print a list of input of the first input. So first input or any input, which is gonna be a string, And then you gotta multiply that list times an integer, which is gonna be a numerical input. Input, enter a number. Okay. And the first input, we say hello again, hello. And then enter a number, then should be 20, I guess. And then you get a list of 20 entries with the first input. Let's solve the last problem. And then in this problem, we're asking for a sequence of digits in the range of 0 to 9. Expect the input to be correctly formatted as follows. Print the median of the sequence in the following format using formatting. The number num is the median of the sequence, where the num is the median and the sequence, and the seq is the sequence. Okay. So we ask for a sequence of inputs, right? And we first ask for, let's call it sequence, input, enter a sequence. And then since the input is expected to be correctly formatted, we do print the median of the sequence. So then we can just forget about the commas, and a good way of doing that is using what do you call it? Let me see. It's called, we can convert it into a list, right? So sequence, or just call it values, equals to the list of the sequence. So far, if you want to see how it looks, you can print the sequence. And I'm gonna do that. I'm gonna print the values. And then I enter the sequence 1, 2, 3, 4, and that's the sequence. I also, I need to, I can do how do you call it? A, Jesus Christ. You can use the method called split. So you split by the comma, but first you wanna strip. So what a strip does is just takes out the white spaces. So if you do this, enter a sequence 1, 2, 3, 4, and you print the values, you should have 1, 2, 3, 4, 5, 5, 5, 5. You should have a list of only the actual characters. And then since these characters are in the range of 0 to 9, and we want to get the median, you have to print, you have to first sort the list. So how do we sort the list? We just call values dot sort. It's a method, and then you'll see that it sorts the sequence. So if we do 3, 3, 3, 0, 0, 0, 0, 1, 1, 2, you get this list here. And the reason it works is because this is a character whose value is lower than character 1, and this character, it has a value lower than character 2. So that's why it works. And then you want to get the length of the whole list and grab the middle number or middle two numbers in case it has more than two. Or, yeah. So this. Oh, we're running out of time. Okay, the meeting is gonna end in like 10 minutes. So in like 5 minutes, I'm gonna stop the meeting and then I'm gonna start the meeting again after the cooldown. Just have that in mind. Then we do the sorting. We have the list sorted and we wanna know the length of the list now. So if the length of the values is even, else, and then we do, if it's even, we grab the two middle numbers. So how do we do that? We grab the length again of the values and divide it by 2. And let's call this middle. And if the length is 4, for example, the middle is gonna be 2. So we need to get the value of 1, of index 1 and index 2. So val 1 equals to values 2, and then val 0 it's equals to values 1. And these need to be integers. So instead of 2 and 1, we use middle and middle minus 1. Yeah. And then we print median is and we do a string formatting. Median is value 0 plus value 1. And these two values have to be divided by 2. Else we just get the middle value, and then we get the middle minus 1, and then we get the integer of that middle, and print the median. Basically, we print the same message, and the median should be values of the middle. Okay, I'm gonna give it a test right now, and I'm gonna stop the meeting. Okay, it's on. So we left off here, and we were trying to figure it out whether this code works. So I got rid of the -1 because it wasn't working, and then I'm trying to get the values here, and we need to get the median, right? So let's see if it was working. So it works for an odd number, but if we wanna give it a try with an even number, it says that list indices must be integers or slices, not floats, and that's because this is a float. So we need to go back here, and then we need to transform it into an integer. And if we do this again, it should work. Well, it's not working yet. Okay, yeah. And we need to transform this into an integer. And then integer again. And if we run it, this time it should work. And yeah, it works. So yeah, this is how you solve the this last problem here. It was a little bit trickier, but just keep in mind that you have to do testing and kind of experiment with by yourself by doing data conversion. Many of the times you'll find yourself doing data conversion wrong or expecting something to happen, but sometimes you have the, the the data type that is not, or you are trying to do some operation between two data types that are not correlated, or cannot, or that operation cannot be done between those data types. So yeah. Any questions? I'm gonna look at the chat right now. No questions. Okay. Okay, there are no questions, so we can just continue with whatever I had planned for today. Yeah. So I'm questioning myself whether I should post the answers for the problems or not. I'm gonna give it another think, and maybe later today you guys can have access to the solutions. Okay, now we are gonna talk about Boolean expressions and some examples. And for that, I need you guys to look at the whiteboard here. And I'm gonna do just some explanation on Boolean algebra. And we're gonna look at Boolean algebra this way. So if you have an and, oh shit, that looks bad. Okay, if you have an and, this is similar to having a multiplication, or similar to having um, this little operation sign, which means and. Oh, and that looks so bad. Let me just erase that. Okay. Okay, I'm gonna choose here. So an and. Oh, sure. And it's similar to having this operation or a multiplication in Boolean algebra. And an or, it's similar to having this operation or a plus. And a false statement, it's similar to having a zero, and a true statement is similar to having a one. So when you do math, and if you do, for example, 1 plus 1 plus 1, and everything multiplied by 0, this is of course 0. But in Boolean algebra, if you have 1 added by 1, added by 1, this is still 1. So as long as you have one value here, this is still 1. This means that a true plus a true plus a true, it's equals to a true value. You can also have a true value added to a false value, added to a true value, added to a false value, and this would always result in a true value, right? And now if you have a true value added with a lot of false values, you'll still have a true value. But if you have a true value multiplied by a false value, multiplied by a false value, multiplied by a true value, this is false, because everything multiplied by 0 is still 0. And that kind of makes sense in logically, but it makes sense in Boolean algebra. And that's why we are kind of taking this mini course to look at Boolean algebra for a little. So let's call in a statement Q, it's equals to today rains. Today rains. And then a statement P, it's today does not rain. Okay. If you say, if we know the statement Q is true, then the statement P is gonna be false. And if we say P in Q, this is always going to output a true statement. So true. Oh, true. Yeah. Some other things are, for example, the statement Q equals to 5 is less than 10. This is a true statement. But if we have the statement P being equals to 5 is greater than 10, this is false, right? And if we say Q and P, this is always going to have to be a false statement or a false value, a false Boolean value, because 5 cannot be equal less than 10 and greater than 10 at the same time. So this is false. It's always false. So that's one example too of always false statements. And then you can have many other statements like statement P, Q, R, S, T, and so many others. And you can do more math with this and translate them into Boolean algebra. So let's erase this and let's look at the input. And this should be an input number. If the integer input of this number is equals to 0, well, that's one example. Another example, if the input is greater, if the same input is greater or equals to 0, the R example is going to be less or equals to 0, and the X example or the S statement is going to be greater than 0, and the T example is going to be less than 0. So if the input, and if we say if P and Q, this can produce a true statement only if the input is equals to 0 or greater than 0. And then if we use the statement P and S, for example, this is going to be a false statement because it cannot be equals to 0, and it cannot be equals to or greater than 0 at the same time, right? It has to be only one. So you cannot have two statements that are totally false being equal. So we say that the statement is not true, and we use the notation not in Python. So we say that not Q when the statement Q, when we want to inverse the statement Q. So for example, if the statement Q it's equals to today rains, and if we say not Q, this means today doesn't rain. So this is what you're trying to say when you use the not before the statement, and you use it in the same way when you write a Python code. So yeah, any questions on Boolean algebra? No. Okay. If you guys got that, we can go back to the screen. Let's see. Let's go back to the screen here. Okay. And let's jump into the data structure, which is in branches. And let me just go a little more deeply on this. So we are right now trying to understand the data structures that Python implements for you. And last time we were looking at list. So we have a list being equals to, we were looking at sets, but we were trying to look to store a list inside a set. But this cannot be done because it's not an unhashable, but it's an unhashable value, and you need to have hashable values for sets. But that will come with you don't need to understand what a hashable value is right now, because that's CS knowledge, and I'm not teaching CS right now. I'm just talking about Python. So yeah, but that's yeah. I can't go too deep into that field because I don't even understand hashable values myself. But what we can do is to import all the values that are in the list in the set. For example, if I want to use all the values here that the list has, I can use asterisk, and then if I run this and I print the list, which is actually a set. So let me put the S there so we can know that it's a set. And if I print the set, I have the values there. I don't have the list itself. I can also store a tuple, because a tuple cannot change, and a tuple can be, it is a hashable value. So you see here there is a tuple there. Yeah. So that's one way of getting around the listing. Or I haven't tried this yet, but I think you can put a list inside the tuple. No, never mind. You cannot. But yeah, you can use a tuple instead of a list. So if you wanna, do you have these values in a list? You can just call tuple here. So you use this, and then you call tuple function to convert that into a tuple. And then you'll have the tuple there. It won't be a list anymore, but you can work with it. That's how you can work around this. um, we also, we are going to look into the loop package. Now we are looking at the loop package, and then we can start by talking about, first I want to look at the methods, because methods and functions, because these are many of the times, or you will find yourself using methods and functions from built in Python already than the ones you are going to be doing. So try to understand this first. Let me start with methods for list. So you have a list, let's say 1, 2, 3, 4, and then 4, 4, 4, and then 0, 1, 0, 1. And then you have the list. And you can use the list. So you do list and then sort in order to sort all the values in the list. And if you want to print the list right after, so you can see that the list gets sorted, you'll see that it's actually sorted. And this is called a method. But what else can you do? There is a function called sorted, but that's a function that will do the same thing here, sorted, and you give the list. But instead of changing the list itself, it's going to return a a new list. So you gotta store it somewhere, and you wanna redefine the list from before with a new list. So you will have it like that, and you'll see the list gets redefined here. Yeah. So the difference between sorted, and sort is that sort is a function only for list. So when you have a list, you can do the dot right after the name you gave it, and then you can put the sort here, which is a method, and then sorted is a function that you can it's not only for list. It also works for other objects. For example, if you want to sort a tuple, and then 0, 0, 0, 0. And if you do sorted on the tuple, you get a list of the tuple. If you want to convert it to a tuple right after, you can do tuple here and do data conversion. And now it's a tuple. So that's one way of doing this. Any questions? The list also provides you with other methods. For example, if you want to add another value to the list, you can do append and then give the value you want to put inside the list. Let's say I want to put 13, and if I print the list right after, I'll get the 13 at the end of the list. So that's one way of adding a list. But let's say I wanna concatenate another list. In order to do that, you can use the plus sign here, and then give a list right after, and then you'll get a new list with the values you gave it. So it's gonna be concatenated. But remember to save it in the same with the same name. That's one way of doing that. If you wanna clear the list, you can call clear. Yeah. Yeah. So Visual Studio Code is gonna help you look for example, some functions or methods that the list has. For example, as you can see here on my screen, the purple boxes represent methods, and the yellow boxes represent attributes. But you don't have to understand the attributes right now. You can only use it to look for methods here. And then if you want to look for functions, you can even, and if you kind of remember the name of the function, you can just type the first letter and then kind of look for the function you're trying to use. This is print and this is power. So let's use the power function, straight to the 2 power or to the second power, and let's print that here. You should get 9, because 3 to the second power is 9. So yeah, that's one way of looking for functions. And I'm not gonna go too deep into all the functions Python has, because I'll never finish. But I want you guys to show you this way so you can you can use it to look for functions yourself. Use Google or any other browser you feel more comfortable using in order to find for functions that do specific things. Um, for example, sorting or converting into a dictionary or doing something like that. Okay, in this package, we also talked about dictionaries. Something about dictionaries is that you can use um, is also data conversion. So you create a dictionary called D, and then you give it a keys of letters and values of numbers. So let's create a small dictionary here with values of numbers. C, C, and then 3. And if you print the dictionary, oh, there's an error here. What? Invalid syntax. Oh, I see. Okay. And then you can see here the dictionary. But if you want to transform it into a list, you can call list on the dictionary, and then you'll get a list of the keys. And remember, you guys, I told you that dictionaries also have methods. So you can do d dot, and then let's get all the items. Items. And you get a list of tuples here. And the first element of the tuple is the key, and then the second element is the value. But let's say you have list or a tuple, doesn't really matter. Let's call it list. And you have exactly that, a list of tuples. And the first value being a letter and the second value being a number. Like this. And then if you want to convert that into a dictionary, and if the list is formatted correctly, you can call dict into L on L, and it will transform it into a dictionary. And I want to print D right after so you guys can see that. And it works. So this is one way of converting a list into a dictionary. Any questions? I'm gonna wait for like 1 minute. No questions? Okay. Some functions that you'll find useful are maximum. If I have a list of numbers or just values, for example, like this, and I put 10, and then I want to find the maximum value from that list, I can use the function max and then call max on the list, and then I'll get the maximum value, which was 10. And similar to that, if you want to find the minimum value, you can call minimum on L, and then you'll get a minimum value. And the minimum value was 1. You can also do, well, you guys been using this, but or you should be using this function called length. It just gives you the length of the list or a string or dictionary or set or tuple, pretty much anything that can be measured in integers. There is also a function called type, which will tell you the type of the object you are working with. For example, I print the type of the name L, and I'll get the name, which was list. You can also print a range. So if I do print range from 0 to an integer. Let's say I want to give an input right now. Enter a number. Enter a number, and I enter 20. I'll get the range from 0 to 20. But if I want to actually get the numbers from that range, I can do a for loop. So I do for number in this range. Just give me a second. I want to see if, okay. And then I print the number. And then I put 20. And I get the list from 0 to 20. But since 20 is not an included number, I don't, the list only gives me from 0 to 19 because 20 is not an inclusive number. So yeah. I can also go in the range from 0 to 20, but in steps of 2. So if I use a step function, the step option of that function, I'll get a range from 0 to 20 in the steps of 2 without including the 20. I can also start from the range of a negative number, negative 20 to a 20, and I get this number like this. And I can even go in negative steps. So from negative 20 to negative 40, I go from negative 20 to negative 38. So the range functions is a function that will be useful for you and for some of the programs I'm gonna be asking you guys to do. If you have a list of numbers, 1, 2, 3, 4, 5, and then you wanna sum up all the numbers and print them, you can call sum on the list, and then it will give you the sum of all the numbers from the list. And then I'm running out of time again, and I think I should be done for today. On the next topic, I'm gonna talk about mutability, which was one of the topics from package 02, I believe here. But I want you guys to read this file first before me going into this file and explaining this file, because many of the problems you will have in some of your exercises will be because you don't understand the concept of mutability well. So please read this file and then read the instructions on the notes here from package 02. Just read the notes on that, on mutability, and then you guys should be good for next meeting, because I'm gonna go more deeply into talking about what mutability is and why that happens. So yeah, just have that in mind. Also, again, some reminders. Today there is no package. A new package will come on Friday, and then the PIB or the put in practice problems for this for package 02 will be due on Monday. Yeah. Any questions before we go, or are you guys good? No.